Hello, this video is created to provide instructions for use with the supporting items in the uh, fitness article. There are three things that I'll go over, although there are five things listed here. First, you have your video instructions, which hopefully you're at now, so there will be a link there once I'm through. And then you have your activity guide. I want to go over the Prairie Dog Fitness game, the Butterfly Applet, and the Excel model. So let's go to the game first. And here we have on the stage a place where when you hit the start button, prairie dogs will appear. And these prairie dogs are supposed to be getting eaten or being eaten by a black-footed ferret. So you'll just click on the prairie dog, and if it's eaten, then a little box will pop up and it will tell you what its genotype is. Now, some of these are faster than others, but you can't tell by looking at them because they all look the same. Also associated with this page is the Excel spreadsheet, and we are at the Game Data tab. So here we have our these orangish areas are areas where you can enter data, and we have our starting big A or p-value, and then we have number eaten. So basically what you do is you put in your p-value and you hit start, and then you start eating prairie dogs as fast as you can. You only have 20 seconds. Okay, once you've eaten the prairie dogs, then you sort them by genotype. And then you count them and place them in the Excel spreadsheet. So here we have 1, 2, big A, 1, 2, 3, 4, big A, little a, and then 1, 2, 3, 4, 5, 6, 7 of the little a. So we have 2, 4, and 7. Go back to the Excel spreadsheet and we put in 2 for the big A, 4 for the big A, and then 7 for the little a. Now what this does is it calculates our new starting p-value based on Hardy-Weinberg proportions. So we take that number 0.53 and we go back to the game and hit reset and then put in 0.53, start, and then try to eat prairie dogs again. And some people get pretty good at it, and I've had one group that ate all of them. I don't know how they did it, but they did it, and I'm not that good at it. So after 20 seconds, they will disappear, and then we sort them by genotype again. And let's see, I have 1, 3, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 1, 3, 10. So we go back here. The next round, we have 1 of the big A, 3 of, whoops, 3 of those, and then 10 of these. Okay, and then our new p-value is 0.59. Now at this point in time, I'm going to increase the speed of the video by 8x so you don't have to sit here and watch me go through it, but I am going to go through the whole game. So the new value is 0.59, and I'll minimize this and put in reset and then put in 0.59. Okay, that's the end of the game. And what we have here in the output is we have two graphs, and we have the absolute fitness and relative fitness as a result of the game. So what the absolute fitness is, sorry, it's based on the population growth. So if the number is greater than 1, it means there's population increase. If it's less than 1, it's population decrease. And the way that's calculated for the absolute fitness for AA is you take 64 divided by 25. And then the same thing for big A, little a, and then little a, little a. Now, relative fitness is a measure of a relative success of one genotype over another genotype. And this is the most interesting because it shows a tendency of one genotype to replace another genotype. Now, this is calculated with the absolute fitness. So, for example, you would take 0.28 divided by 0.28 to give you your relative fitness. Then you take 0.63 divided by 0.28, and then 0.16 divided by 0.28 to get your relative fitness. Now, this is an indicator of directional selection, which you'll see later with the other Excel spreadsheet, which is located at the mathematical model. But you can see based on this particular game, we had an increase in the dominant allele and a decrease in the recessive allele, and we had directional selection toward the big A, big A. Now, the next thing I would like to show you, let me go back, I'm sorry, is the butterfly applet. Now, this is not as complex as the game, but it's still pretty good. Basically, what you have here is control or a start of number of butterflies. So you can count the B1, B2, B3, B4, and B5 colors of butterflies as your starting value. And then you select the model and the values change. Now you could graph these, you could do, put them in a table, whatever you wanted to do. But you have one model that is stabilizing selection, the next one is disruptive, and then the final one is directional selection based on the butterfly model. Okay, so let's get out of that and let's go back to the spreadsheet. So here, if you remember from the Prairie Dog game, we have our relative fitness values, and these relative fitness values resulted in directional selection. So with the mathematical model, what you do now is you have your starting p-value, and then you can put in whatever fitness values you'd like to put in. So let's see, suppose we just put in a 0.8, 0.5, and a 0.9. Okay, that gives us a disruptive selection or a type of disruptive selection looking at the graph. If we went with just one here, and then one there, it would be a very classic look at disruptive selection. And what you can do with this is just play around with the values. You can also play around with the p-value and look at the various types of selection that pops up. And it also gives you the change in alleles. And that's the end of the instructions. Thank you for listening.